Hello everyone. Today I would like to show you a simple example of the calculation of the cylinder drives. So, what actually impacts the calculation of cylinder drives? What are the criteria we need to remember? First of all, we start with the calculation of existing cylinders. Imagine we have a cylinder with the diameter of 63 millimeters, and we have two or three of them. They are all operated by by the valves. So we would like to have I want to have 5 valve here for each of them. So we simply connect it, and okay, perfect. So we copy, and let's see how we can study an impact of various parameters. We would need to have a couple of connectors. We will create today a simple version without regulators, just to show you how it works, studying impact of various energy saving measures. And this one. So let's see, it's going to be like this. And as well as we would need to have here the basic element, we call it source, or we call it the drive. So perfect. Now we need to have to parameterize each cylinder. It works on 6 bar, stroke, travel time. It's going to be 3, length of tubes, as well as the amount of cycles. Perfect. So now, of course, the program will ask us also about other cylinders, but let's make it actually simple, and we copy all the parameters. So don't consider now the regulation of the velocity, because I would like to show you only the choice of cylinder drives and the main parameters that impact it. Okay, so press on calculate. And let's see. So each cylinder now, operation of each cylinder cost 10,000 euros per year. What are the energy saving measures that we can apply here? So first of all, of course, we need to see if the cylinder is sized correctly. Correct sizing going to be number 1. Now let's do it here. Correct sizing. Here we saw that the cylinder is calculated for the force of 1600 Newton. So we just need to be sure, do we really need 1600 Newton? Maybe it's less, maybe it's only 500, and our cylinder is oversized. So we calculate here, and that's true. The calculated diameter here is 38 millimeters. And the next cylinder that we should choose is going to be 40 millimeters. So we change it here for the cylinder 40 millimeters. We recalculate also other parameters here. Let's do the, we said 500. So we need it just to be sure that it's correct. Direction of the movement, the mass. And here now we have actually an efficient cylinder. Let's put it here. And this is already the version of the efficient cylinder, the technology that is available on the market. The cost of this for this application, it's 2,900. But let's check the same application for the same force. So I would like now to change the force here and size it correctly and say that I want standard cylinder. Change it. And if the cylinder size correctly is 4,245. If we use alternative technology that allows the to adjust cylinder on the required force, the savings are uh, about around 30%, right? So the cost will be 2,900 in comparison to 4,200. And remember that here we saw that this cylinder was that we had at the beginning of diameter 63 millimeters, and the cost of this is 10,000. Of course, the bigger cylinder provides the bigger force. However, we always need to note and remember that most of the time this force is not required for this application. And in this case, we always need to recalculate and to be sure that our system is not oversized. By oversizing cylinder, we also oversizing other components such as connectors, such as pipes, such as valves, and this is very important. Yes, here don't forget to put also exhaust to each valve. So just connect it here. And here you can see how much your system will cost. So the system operation of the all three cylinders will be 17,000. If we had three cylinders with initial cost of 10,000, it will be 30,000. Savings more than 50%. And to take a final decision, don't forget to calculate the total cost